so, you have to import your pandas module first. You're going to import pandas as PD, and then we're going to store our data into a list. Okay, so inside the list, each item will contain a list also. So this list will be each row. So each row will contain the name, your age, and your salary. So this row 1 will contain Alex 20, 1050. Row 2 will contain Bob, and so on and so forth. So after you have created your data from the list, next thing is to create a data frame, right? Because we want to present our data into a table format. So how do we do so? To present a data, put into a data frame, we use the function pandas.dataframe. Okay, and then we include the data that we have just created and assign the columns. Okay, so when I run the code here, you should be able to see a nice data frame at the bottom. Okay. So next part will be to create a list of dictionaries. So this is another way of creating a data frame if you want to put the list into put a dictionary into a list. So instead of having a list inside, we have a dictionary inside. So in a dictionary, we have keys and values, right? Key value pair, that's what a dictionary is. So if you look here, the keys, right, will be the columns, the column name, and the values will be the data that you want to put inside. Okay, so each item inside also represents a row. So the first row, I'm going to have my name, Alex, my age 20, and your salary. So it's the first row, Alex. Second row will be Bob. Third row will be Cat. Okay, so similarly, we create a data frame by using the function pd.dataframe. Be careful, it's capital D and capital F. Okay, pd.dataframe, and then we put in our data that we have just created, and we put in the column name in a list. Okay, you need to be careful here. The column name, right, must be exactly the same as what you have put in the dictionary, because if there's a slight error in like capitalization, there will be an error inside. So after you have created this data frame and assign it to df, we'll just print out the data frame. And if you do so, you will be able to get this thing here. Okay, it's the same thing as what we have previously, but it's just a different method of creating data frames. So other than data frames, inside pandas, we have something called the series. So series is a row or columns of a data frame. So instead of being a table, right, like a data frame, it just either takes a row or a column. Okay, it's either horizontally or vertically together. Okay, with that, right, you guys can try creating your own data frame. Try creating a list of lists or list of a dictionary, both of them. Okay, I'll give you around like 2 minutes. And if for those who have just came in or so, you guys will have access to this PowerPoint slide and also the sample codes over here. The link is in the chat. So you can go to the sample code here and go to the session 1 version 2. Okay, and then you have access to the codes that I have over here. I'll send the link again to you guys. Okay, so you guys can try creating a list of list or list of a dictionary and then print out that data frame. Okay, so let's move on after you've created the data frame. So at this point here, everyone should be able to understand what a data frame is and how to create a simple data frame. Okay. Okay, next up, structured data sets. So as I mentioned earlier, we're able to read different data files inside Python, or yeah, we can read CSV files, JSON, and also Excel files, and many others. So what are data formats? So many data are downloaded or stored in different formats. So the Python is able to read all this data file and use all the data inside to perform different analysis on it. So the common data formats that you guys will be able to see on use for this data analysis is CSV, JSON, Excel, and XML. So for this course, we're going to focus on CSV. You're going to learn how to read CSV files and perform different pandas functions on these CSV files. So the other files, JSON, Excel, and XML, they are included inside the appendix in this slides at the bottom. Okay, so don't worry, you still have access to this knowledge. You can just go through them after the session today. So CSV file, which stands for comma separated values, is a simple file format that is used to store tabular data, and you can access them using spreadsheets or even like Microsoft Excel. Usually if you open it on like Notes or Notepad or whatsoever, you're able to see values in each row, and all the different values are separated by commas. So those are usually CSV files. So next up, we have JSON file, which is used to transmit data between server and web applications. And then XML, which is the extensible markup language that is used, is to store or transport data in HTML applications. So HTML is usually used to format and display some data, while XML separates the data from this HTML. And last but not least, we have Excel, which many of you guys should be familiar with, Microsoft Excel. And you guys probably 100% would have used this before. So, okay, sorry. CSV file, which is comma separated value, as I mentioned just now, most people know how to use this, and it's easily viewed by different people. So CSV file is a human readable text file. So if you open it on Notepad, you're able to view and understand the different values, because some of these files, right, you are like in funny language and you're not able to read those, but you're able to read CSV files. Okay, so how do we read CSV files? So in Google Colab, you just have to use these commands here. From Google Colab, you're going to import files. And then you click on, and then you write this upload equals to files upload. So when you run this program here, you'll see a little, you see a pop-up here, which asks you to choose a file. And it will bring you to your computer where you will select the different files. Okay, so for example, over here. Okay, I'll load this. I'm going to load this command over here. So when I run this thing, you're going to see this pop up here, and I'm going to choose files. So when I do so, it'll be brought to your computer drive, and then you just have to select the file that you want to upload. So for the next question, the file that we're going to upload, right, is the Unit 5 data CSV. So when I open this file, you see it take a while to be uploaded. And when you see this 100%, that means the upload is successful. Okay. So the files over here can also be found inside the notebook in the Google Drive that I sent to you guys inside the data files. So you can download the data files for session 1. So these are the different files that we're going to use for this whole lesson. So the one I just uploaded was Unit 5 data CSV. And also one thing to take note, right, is when you're using Google Colab, is to use Google Chrome, because if you use some other website, you might not be able to load this command here. You will not be able to upload the file. There'll be some error message being shown. Okay, so use Google Chrome when you are using this file upload. Okay, so after you have successfully uploaded the file, the CSV file, right? The next step we want is to be able to read the file, right? Read the data in the file. So how do we do that? We use this read CSV function, okay, in pandas. We're going to read the CSV and store it into a data frame. Okay, so over here, pd.read.csv, and you write the file name that you have created, you have uploaded, and assign it to store it into a data frame. So after you do that, right, basically this question is a tuberculosis question where it shows the number of people who got tuberculosis in different countries and in different years. Okay, so for example, we want to find out the total number of cases of tuberculosis per 100k people in Singapore from 2000 to 2016. Okay, you want to find the total number of tuberculosis, the people who got tuberculosis in Singapore within this period, 2000 to 2016. So how do we do that? I'm going to explain this extraction process later on in more detail later. Yeah. So we just have to call a data frame and put the column that we want and assign it to Singapore. And then we get the sum of it. Okay. So I'm going to explain line 4 and line 5 later in greater detail in the following later on. So now the main focus is just to be able to read the CSV file and upload it and read the CSV file. Yeah. Okay. So this is a data frame that you have. You have different countries, and you have the estimate incidence of per 100k population here, and the different countries. So we're supposed to find Singapore, right? So the main focus was Singapore. So I just put my country, which is the column name. You must put exactly the column name, okay? If it's a capital C, you put a capital C. If not, yeah. And you want to check if the column is Singapore, then you're going to assign this data frame into another value SG. And then we want to find out the sum, right? Total number of people who got tuberculosis in Singapore. So we just use the function .sum. This estimate incidence, right, is just one of the one of the column name. You want to sum up the total number in Singapore. So when I do that, you get a number 700. You get a sum 700. Okay, so with that, right, I'll give you all 1 minute to, okay, 1.5 minutes to load the data, CSV, the Unit 5 CSV, and yeah, put it into a data frame. Okay, and if you want, you can try to do this. Find out the number of cases of tuberculosis per 100k of people in Zimbabwe, okay, from 2000 to 2016. Okay, I still see people asking about the slides. So I'm going to send the link again to the chat. Okay. Yeah, so you just go to the link, download the different files that you need, the sample file, the data file, and the codes. Okay, what to type to download the files? Yeah. Okay, you need to upload the files and then read the CSV files. All these codes that you see now are inside the link that I provided to you guys also. If you can't upload the file, please check that you're using Google Chrome. It's Google Colab with one L, okay? Someone asked you can't do that because you put 2L. Okay, so let's continue on to just load the files, guys, and read the CSV. Yeah, because we have a lot of slides to go through, okay, so yeah, that's why the practice session is quite short. So don't mind me. You can always refer back to the PDF files here and the data files on the Google Drive. Okay, so at this point, everyone should be able to open a CSV files and put it, load it into a data frame. Okay, simple. Okay, next up, we're going to move on to data processing. So we're going to further use pandas to be able to load all those files. Okay, so what are the different methods we're gonna learn? We're going to learn how to extract a certain column, a row, do groupings, uh, filtering, joining the different data. For example, you have two data frames. How are you going to join it? By rows or by columns? And also pivoting. Okay, pivoting, you hear it very common in Excel, right? Every time when you go for job interviews, they always ask you, do you know how to do pivoting in Excel? Yeah. So actually, you can do it also in Python in Pandas. So we're going to learn it here. Don't worry. Okay, so first, given the data frame that we have, how do we extract out a certain row? Okay, we use the log function, okay, LOC. So for example, we have a data that we have created just now, similarly. So we just put that data into a data frame. So in this data frame, we have name, age, and salary. And we want to get the row, the first row, which is index 0. So remember the indexing in Python starts from 0. Okay, in the list, the data indexing starts from 0. So they're getting the first row, which is index 0 from the data frame. So you just put your data frame dot log square brackets the index. Okay, and you print that. So over here, okay, here. So this is a data frame that we have created earlier on. So you just load it into a data frame, and I want to print the first row. Okay, and got it. If you want to see the data frame, right, df, you just put print df, and then you get that. Okay, so this is a data frame that we have, and we want to print the first row, which is Alex 20 and 1050. So you get this. Okay, we print the rows by index. And then next up, how do we extract a column? So, so the same thing, we have a data frame. We put the column name inside the square brackets. And you must ensure that the column name is of the correct capitalization. Okay, if it's small n, we must put small n. Okay, so using the same data frame, the data Alex Bob Cat, I'm going to extract out the names only, the column names. And then there you go. Alex Bob Cat. And you realize the indexing starts from 0, 0, 1, 2. Okay. Okay, now you guys can try 1 minute to extract the rows and columns. Okay. So try that out. Extract your rows and columns. 1 minute. Okay. Okay, some people want to look at the codes. Okay, so I'll show you the codes instead of the questions. Okay, so I'll just continue, okay? Okay, so to recap, to extract rows, we use the log function and put the indexing in square brackets. To extract a column, we just put the column name inside the square brackets also. Okay, so the next part we have here is on grouping and aggregation of pandas. So given the data, we want to group the data into a certain groups and then perform to calculate different things. Like for example, I want to calculate the mean scores inside class A, B, and C. Okay, so we're going to group the data and then perform calculations on it, which is aggregation. So for example, given this data over here, so they imported pandas and then they have a list of students, the list of class of each students, the age of each students, the scores for each student, and then they created a data frame of it. Okay, so this is another way to create data frame. So they just put it into a dictionary. So the keys for this case will just be the column names, and the values will be a list, will be the list that you have created students, and then this is the column class, and then they have the list classroom, so on and so forth. So after they have this data in a dictionary, what they do is to transform this data into a data frame using the method pd.dataframe. Okay, and then they just print the data. So if you do so, it will be over here. Okay, so I got my data and I just want to put the data into a data frame. And then you have this, okay, your students, class, age, score, nicely in a table format, which is data frame. Okay, you can add a print also, can print df. If you put df also works. So with this data that we have, the different scores in the different class and students, we're going to group them and perform aggregation on them. So we're going to use the function group by, and after that, we'll pass aggregation on it. So how do we use this aggregation function? We put we group them into as a dictionary with the aggregation function. So for example, this dictionary takes in the column that you are aggregating as key. So given my data frame that I have just now, I will group the data into classes, and I'm going to get the scores, the mean, median, the mean, the minimum score, and the maximum score for each class. Okay, so the aggregation function I'm going to use is mean, minimum, and maximum. So I'm going to put those in a function, and because I'm going to do all this on the score, so the scores here will be the key, and the values in the dictionary will be the aggregation function. Okay, I'm going to show you guys. Okay, you guys might be confused. So for example, like that. Okay, this is the data frame that we have. So in line 8, let's look at line 8. Okay, they use the function group by. They're going to group by a class and then perform aggregation on the score. So the score, right, will be in the key, will be the key in the dictionary. And the value, right, that means what are the aggregation functions that you're going to perform on this score. I want to find the mean of the score, the minimum, which is mean for short, on the score, and the maximum, which is the max for short, the function max. Okay, all these mean, max, right, the built-in functions in Python, which you guys should already know. Okay, so when I do that, you will get this. Yeah. So with my with my number of the data frame that I have just now, I group them into classes, right? A's and B's. So I have my group class A and class B. Then after that, I'll get the mean. I want to get a mean score. So I have a column of mean, a column of minimum, and a column of maximum for each class. Okay, all these numbers are the mean score of class A, mean score of class B, minimum score of class A, minimum score of class B, and maximum. Okay, so you can change this up, put different building functions inside, aggregation functions inside, and then you can see what happens. Okay, I'll give you time later to practice, so don't worry. So next part here will be grouping by multiple columns. So just now, if you realize, right, we're only grouping by class. So what is the case? In the case we want to group by more stuff, okay? So what we do is we put a list of column names into the group by function instead. Okay, so over here, other than grouping by class, I want to group it by class, and also each class I want to put in a different age and find the mean, minimum, and maximum. So I just put each class, the column class, and the column age inside a list in the group by function. So when I do that, you should be getting this over here. So now other than classes, right, I group them by age also. So it's like a subclass kind of thing. Okay, and you got my mean, your minimum, and maximum. Okay, so this is very this is common to group, important to know inside pandas. Okay, now you guys are gonna practice. So I give you time around like 3 minutes to do so. Okay, because this one have many data. Okay, so you can try to group them into different columns and perform different aggregation functions on it. So other than mean, minimum, and maximum, you can try putting other things, your mode, your median, and stuff. Okay, so try this out using group by and your aggregation function. Okay, I think some of you guys are not able to download the files, so give me a moment while I fix it. Okay, you should be able to download the files because it's made available to you guys. So if you go to the link that I sent, go session one, right click and click on download. You should be able to download it. Okay. Okay, with that we'll take a 5 minutes break and then yeah, and we'll come back at 7:05. Okay, I will try to solve whatever questions that you have posted. Okay, so see you guys at 7:05. Okay, I'm going to continue now. So you guys, I see you guys, some of you guys still have a problem like uploading files and downloading files. So I'll go through again, slowly, okay, slower, not serious, slowly. Okay, given the link that you have just now, if those who cannot view the sample codes, you click onto the file here, click on version 2, and open with Google Colab. Okay, at the top here, open in Google Colab. And you'll see the files, the exact same file that I've been running. Okay, it's taking a while, so yeah. So it's exactly the file that I went through with you guys. Okay, and then the question on how do we upload a file, a CSV file. So just like I went through just now, what you have to do, right, is to make sure you're using Google Chrome. You type in this codes here, you're gonna import a file. So when you play this, when you run this code here, you'll see a pop-up here. Make sure you are selecting the file that you want to upload. So click on choose file. And then just now we upload the data, unit 5 data CSV file. Okay. And I click open. When you do that, once it's successfully uploaded, you'll see this 100%. Okay, so this file is uploaded and you should be able to see it on your Google Colab here. See, I have a few because I uploaded a few times. Okay, unit 5 data CSV. Okay, I click on this button here. So once you have uploaded the file, how do you read the file? You need to import pandas first because I'm going to use the function read CSV that is inside pandas. Okay, you have to import pandas as PD. So PD for short. So therefore we use this PD. Okay, if not, we're going to write the full word pandas, which we don't want. So we're going to write PD dot the function is CSV because this file that I uploaded is a CSV file. Okay, and then I have to put in the actual name that I uploaded. So this name here. Okay, and I put it in a string format. Okay, so after that, I put this data frame into the variable df. Okay, and then after I've stored this data frame into df, I will just print out the data frame. So I just put df, which is a variable that I stored inside, and I'll get the data inside your file. Okay, so I hope that clarified all the questions. Because yeah, I saw a few questions on it. So yeah. So I'm going to move on now because we still have a few more things to do. So if you want, right, the extra practice to group, just like we did on grouping and aggregation, you can always load the XLS. So XLS is an Excel file. So how do you read Excel files? You have to change the function. It's no longer read underscore CSV. Okay. So if you don't know, Google them up. Okay, it's very easy. You just Google how to read CSV file using pandas, and you'll be able to do it. Okay. So you can perform different groupings and aggregation functions on this data set here. So let's move on. And now filtering. So given a data set that we want to filter the data based on the different columns and different rows that we want. We want to choose a certain column that we want and a certain row that we want based. Yeah. And pandas can help us do that, which help us to slice and dice the data in multiple ways. So often we want to subset the pandas data frame based on one or more values of a specific column. So let's look at some example. Going back to our tuberculosis example, So just now, the tuberculosis was the unit 5 data CSV file. That's the tuberculosis file that we have. So we are going to we're going to extract out a certain column. Okay, so one way to filter out rows, just now I mentioned use a log function, right? A log function, you need to put in the index. But for now, right, you want to put in, like, for example, that's how we saw country equals to Singapore, right? So actually we extracted out pandas using a Boolean expression. So what is a Boolean expression? Boolean. So if you guys should really know what is Boolean. Boolean is a data type inside Python that returns a true or false answer. Okay, so we get a Boolean expression, and then after that we put a Boolean expression into the data frame to create another data frame. So we create a Boolean variable by taking the column of interest we want. Just now was country, and then after that putting that and checking if that value is equals to a specific value that we want, whether country is equals to Singapore. So for this case now it's no longer country. Now they want year. Okay, they want to print out the rows that are equals to 2002, sorry. So they put the df year equals 2002 will return you a Boolean expression. So they are comparing if the row year, right, if it's equals to 2020. If it's equals, it will return true. That row will return true. If it's false, that row will return false. So this Boolean expression, they put it inside the original data frame. So what this does, right, is they'll print out the rows that are true only. Okay, they'll get the rows that are true, and then they're assigning this data frame into year 2002. And then after that, they print out that year 2002. So let's see here. Okay, here. So I've already uploaded the file just now. So I just have to read the CSV file and assign it to DF, because just now DF was updated to this one. Yeah. So I want to update DF to be this. And then, okay, I will show you guys what does this do. So for example, if I just print this up, it should return me a Boolean expression, as I mentioned. So it's either a true or a false answer. Okay, so you get a row. If the year is 2002, it will be true. If it's not, obviously it will be false, right? So this inside here will return you a Boolean expression. Okay, then after that, I'm assigning this Boolean expression into the data frame. Okay, so when I do that, what do I get? Is the rows, the entire row that is equals to 2002 only. Okay, so these are the rows that are equals to 2002. Okay, so you realize all the years is only 2002. Just now previously was between 2000 and 2006, if I'm not wrong. Yeah. So if you want to see the original data frame, you can always print BF at the start. And then, so this is the original data frame. We have 3,651 rows and 7 columns. But after you filter them with only printing 2002, you got 2013 rows. Okay, so this is what we do. We put the expression, Boolean expression, into the data frame. Oh my. Okay. Yeah, so hold on, later I'll let you practice. Don't worry. So after subsetting, we'll see a new data frame which is smaller in size, which I explained just now. So next up, just now I print rows that are equals to 2002. So how about rows that are not equals to 2002? So basically, we just put, if you have learned Python before, not equals to just either, exclamation mark, right, equals. So instead of putting two equals sign, I just put an exclamation mark equals, which represents not equals to. So if your data, if your year, the column year, right, the data is not equals to 2002, you're going to get, yeah, you'll be true. Okay, and you're going to print the rows that are not equal to 2002. So these are the things that you get. Okay, we just put not equals. And then next up, select rows whose column value is NA. So for example, in a normal data frame, if you have an empty data, if you have columns, certain column that has an NA value, right? We just put not now. Okay, if it's not now, that means if it's not empty, then I'm going to print out that row. Okay, this one they use the dot formation. So it's the same thing. So just now previously, right, I mentioned to you guys to extract out columns, we just print out. Okay, wait, let me explain this. So for example, if you want to extract out the year only, right? So df bracket year, you get the column year, right? Another way to extract out row, a column, is using the dot. So dot year, and then you get the same thing. Okay. So what they're doing here is they're finding the column year that is not now. Okay, so in a column year, the values that are not now, they're going to print out that row. Okay, so this is another format to print out columns. But I will recommend you guys to use the square brackets format. Why? Because in the case where your column names, right, is very long, like for example, this one, estimated incidence, and there's spaces to it. So you can't possibly type this one, df dot estimated space year, right? There's a space here which doesn't make sense, right? So in this case, you only can use the square brackets to call the column. Okay? But sometimes the dot method is faster. Yeah, so it really depends. Yeah. Okay, so going back to here, yeah, they called the year, the column year that is not now, using the not now function. Okay, so before I move on, I'll let you guys practice first. Around like 1 or 2 minutes. Okay, try to print out year, extract out a certain column using this Boolean expression, equals and not equals to. Can use the data, unit 5 data. Some question, yes, you can filter the columns based on more than one condition. So later I'll go through that, don't worry. But if you want to try, go ahead and try. Okay, so yeah, let's move on. So just now we learned how to select row based on the Boolean expression. So next up here, we can have to select rows based on using the is-in function. Okay, data frame is in. So we want to select the rows. We can use list or any other iterable. So if we use this is-in function with the single column, it will result in a Boolean variable also with true or false, as I mentioned earlier. So in this case, right, instead of comparing, right, they just use the is-in function. Is in what? What is the list or other iterable that you want to include? So years in this case is 2000 and 2008. Okay, so they're printing between years. They're printing the columns with years equals to 2000 and 2002 and 2008 using the is-in function. So when you do so, you get this. Okay, with 2002 and 2008. And then similarly, if you don't want uh, if you don't want 2002 and 2008, the negation of that, right, is no longer the not equals, but we're going to use this curly bracket, curly line, okay, not bracket, curly line, which represents the negation, means opposite. Okay, so the opposite of 2002 and 2008 means yeah, any values other than that. So this expression here, right, will print out true, false answers, right? But the negation of this expression means all the true values, they're going to change it to false, and all the false value, they're going to change it to true. Okay, they're going to negate the expression here and get the inverse of it in that sense. And you get that. So this one will print not 2000 or 2 or nor is it 2008. So when we do that, we'll get this. Okay, we're still using the same data file, unit 05, the tuberculosis one. And you get this. Yeah. Okay. Okay, just now someone mentioned you can select multiple rows or columns, right? The answer is yes. You can use just now that is in and then put in the list, or we can use the and. Okay, so for this case, right, we are selecting different rows. We want the years, we want to select a certain row, years equals to 2002, 2008, and also country being like Singapore. Okay, you have two conditions now. So in order to include conditions, we use the sign and not the and, unlike in normal Python syntax. So in this syntax, we use the sign and to include more than one conditions. So they're selecting based on the years. The condition is the years must be 2002 and 2008, and the country they only want in Singapore. So over here, they combine the conditions using the and sign. And then you get just these two rows. Yeah. So in Singapore, these are the two rows that you get. Combining condition using the sign and. Okay. So now it's time for you guys to practice again. So you guys can select data from 2002 and 2008. And another question is select data between 2004 and 2008 that are not from Singapore. So two conditions here. And I'll leave the slide here. Okay, some questions. I saw this question where they ask like, why did I put selection instead of print selection? Because in Python, in order to print something, you have to use the print function, right? Yeah, you can do that. Okay, so in Google Colab, right, it allows you to print a variable without adding the print function. But for example, right, if I put df here, okay, I don't want this selection first. If I put df here, it will print for me the data. Okay, even print the data. Where's the data frame? Okay, you print for me a data frame here, right? But if I write other stuff right now, and I put selection, it will just print the last one that I have, selection. Unless I add in the print function. Print means I want to print both the data frame and the selection. variable. Okay, then you print for me both things. Yeah, so it's a good habit to always put the print function, but if you don't put it, it will just print the last variable that you put inside your program. Okay, so if we just put selection, we just print the last one. That's for how the Google Colab works. Okay, moving on. Okay, wait, let me go through this answer first. So how do we select data between 2004 and 2008? Okay, so just now we went through how to select 2002 and 2008, right? But now I want to select values between using a range. So if you guys have done Python before, which you guys should really have, there's this range function, which will print out the range between 2004, the starting value to 2004, and the ending value, which is exclusive of it, right? So if we want between 2004 and 2004, 2005, 2006, 7, 8, right? So we need to exclude 2009. Therefore, 2009 will be our ending value. Okay. So a range between this value, the year, your year, whether it's inside the range, this value, and the second condition is the country, Singapore, is not Singapore. So I just negate this. And then you should get answers here. Okay, all the years between 2004 to 2008 using a range. So the starting number is inclusive. The ending number here, second argument here is exclusive of the ending number. Okay, sorry, let's move on. Yeah, I'm sorry I'm going too fast, but because we have a lot of things to cover, you can always recap going back to the notes and the sample code, okay? Just go to the link. It will be there. So joining data from multiple data frames. So now, for example, I have, just like I mentioned, if for them I have two data frames and you want to join these two data frames together, either by the column or by the row. So how do we do that? Okay, there are many ways to do that, but one example here that we're going to use later is called concatenate, concat for short. So here, we have two data frames. First one is just DF1. So we have the students, class, age, score, and I put all this data into a data frame called DF1. So DF1 is my first data frame. And then the next one, I have another set of data. Charlie, James, Ethan, class, age, score, and I put this data into data frame to DF2. Okay, so I want to combine these two data now. So because this one is only class A and B, this one is classroom C. So in order to combine these data, I use the function concat. Okay, pd.concat. So I have my first data frame, DF1, and I'm going to join it with DF2. So I put them in a list, and my second argument will be ignore index equals true. So you put this inside first, and then you see what happens. So you run this, right? You will have you'll join the two data frames together using this concat function, and you get class A, B, and class C. Okay, I'm joining these two data frames using this. And then what happens if I don't add in this thing here? So I remove the ignore index equals to true. When I run this, you realize that the indexing is kind of weird, right? So 0 to 6 is your first data frame, and the next 0 to 2 is your next data frame. Okay, so we don't want to do that. We want from 0 all the way to the last number. So therefore, we're going to ignore the index that is originally in our data frame. Okay? And then here we go. Okay. So this is joining the data frames by rows. So the first data frame and then the second data frame below by rows. However, in the case where we have an extra column that we want to add, like for example, a class, we have this class score, we got maybe a math score. Now we want to add in the science score. So in order to do that, right, we just assign the axis parameter to be as 1. Okay, but in this case, for our case, right, it doesn't make much sense to join them using column, right? So you guys can try now to join them by rows and try joining by columns and see what happens. Okay, that should be quite okay, not very difficult. So just now I mentioned that you can join using rows, right? And then for this case, if you're gonna join it using columns, we just put axis equals to 1. So, but now if I do this, you realize that it becomes weird, right? So this from column 0 all the way to 3 is my first data set, and from columns 4 all the way to 7 is my second data set. Okay, and it's very weird. So for this set of data, we just join it using rows, and we use pd.concat. Concat is concatenate, which is joining for short. So next up here, we can merge the data also using the function merge. Okay, these are the different functions that you can use also: concat, merge, join. But for this case, we're going to cover merge on merging columns. So just now we learned how to merge column using concat. Now we're going to learn how to using merge. So given now we're going to make another data set, okay? So now this data set will include ID. So just now was class A, B, right? With only age, score, a class, age, and score. But now I have another column, ID. Okay, so I have students, my ID, and I create a data frame df3. So I'm going to merge it using by columns now, because I have extra columns. So I'm going to use the function merge. So just like I have to include the original data set that I want, and then what I'm going to merge with it. So the original data set was df row, which was this data set we merged just now. Okay, df row, I'm going to include a new column ID. Okay, and be careful, right? The students, right? Student 3, the names here are exactly the same as this here, your original data frame. Okay, so now I'm going to add it to create a new data frame called df merge column. Okay, not this one. This one is here, merge column. So now you realize now there's a new column here, ID. Okay, and this on, right? That means which is the column here that coincides with the between the two data frame, which is our students, right? So the column named students are the columns that coincides between the two different data frames. So you guys can try this out now. So create another data frame with another data set and then merge them using the merge function. And then see what happens if your order of names are different. For example, you swap Bob and Anna. And what happens if you change one of the name? Like for example, you change Anna to Ben or something. Okay, and then see what happens. So I'll give you time. You can try these questions out. Okay, someone mentioned, right, just now, why just now when I merged my columns in my previous example, why are there all these any ends? Because you realize that if I merge by column, right, okay, look at the second data frame, there's only one, two, three data. But for example, my first data frame, there's one, two, three, four, five, six, seven. So you got seven rows here, but your next data frame only got three rows. So obviously the next few rows are empty, right? So therefore you have an NaN, right? So NaN, right, is empty things, and we learned just now how to exclude all these rows or columns. Okay, later we're going to learn different ways also. So NaN means there's like null or empty thing. Okay, so let's move on. So other than merging using by columns, another thing that we will learn now is pivot tables. Okay, so pivot tables, interesting, right? You guys have all heard this before, pivoting inside Excel. So we also can do this pivoting inside pandas. So how do we do that? So what actually is pivot table? It's a table of statistics that summarizes the data of a more extensive table. So you want to perform more calculations on a more customized table. Okay, it shows the breakdown of values. For example, for the first column, it displays values as rows, and for the second column as columns. So what's the function that we use inside pandas? It's called pivot underscore table inside pandas. And it also supports aggregation function, okay, which is aggfun for short. So if we don't assign this aggregation function, right, it's assumed to be the aggregation function, it will be the mean. Okay, so when we're calling this pivot table, if we don't put aggregation function, the default is just mean, which calculates the average. So for example, using the example that we have, we want to group them by rows. The rows we want it to be a class, and the columns we want it to by each. And we want to calculate the average score. So what we do, we want to get this. Your pivot table should look something like this, where the rows are the class, the columns are the age, and all these numbers are the mean. So NaN, that means it's empty. They cannot calculate the mean because there's no values given in the data. So how do we form this table? We use pivot table. We call the what's this data frame that we have first dot pivot table, and then index would represent the row. Okay, the row we want to put is class, and the column is age, and the values inside here are the scores from our data frame. Okay, and then this fill zero at the end, fill value equals zero. That means all the empty values, all the NaN stuff, we don't want it to put NaN, but we want it to put a value zero to it. So it's zero. And I mentioned just now, if I don't include this aggregation function, right? Where is it? This one, aggfun, right? It will be assumed to be mean. And because we are calculating the average score for the different classes and each, I don't include the aggregation function. So when you do this, so these are the data sets that we have created just now. DF1, DF2, and then DF3, and then we merge it. DF1, DF2, we merge it by rows, and then we merge data frame 3 by columns. Okay, and then we assign it to be merge, DF merge call. Okay, so I'll print this final data frame for you to see first. what this data frame is all about. Okay, so this was a data frame that we have just now. Oh yeah, sidetrack. That's why someone asked me how do I add in uh the hashtag. So in normal like idle or what, you can just highlight and press alternatively. But in this case for collab you can't. So you have to manually put it. Unless someone can find a solution. Yeah. So anyway, this is the original data frame that you have here. And I'm going to create a pivot table. I'm going to group them by class and then the score, and I'll find the average. And I want to fill the value to be zero, or the empty values to be zero instead of NaN. Okay, wait, let me, and then here, you get the final data frame here. Okay, so instead of having NaN like previously, that's what you saw in the slides, now my empty values will be zero instead. And just here just calculates the average score. So you guys can try that. Calculate, but instead of calculating average, right, I want you to find the maximum and minimum scores by class and each and set the missing values to zero. Okay, so here. So this question here just finds your mean. But my question for you is I want to find the maximum and minimum value, yeah, of the scores. Okay, so you have to do something with the aggregation function. Okay, let's go through now. So the question was you're supposed to calculate the maximum and minimum score by class and ages. So instead of having just calculating mean, you if you guys didn't know, you can just Google the pandas documentation or whatever and find pandas pivot table, and then you see here. Actually, here they include here the aggregation function as I mentioned just now. You can either put in a function or a list of functions. Okay, by default, you just calculate the mean. So my question to you was calculate the maximum and minimum. Since there are two, we're going to use a list of functions. So here, I'm going to put func, F-U-N-C, equals to F-U-N-C? Yes, F-U-N-C. Equals to a list, right, of the different functions. So minimum, M-I-N for short, and then maximum. Okay, a list of different functions. And then now when I calculate it, you will get your minimum and then the maximum. So the minimum score for class A age 15 is 80, so on and so forth. Okay, quite simple if you have Googled the documentation. So very important, if you're unsure of the method, always Google for the documentation. This is your best solution. Okay, checkpoint, everyone should be able to create the pivot table. So you have a data frame, and then you want to put the row into the index and then the column. Okay, you have the index as the row and columns as columns. And then what do you put in the table? The score. So with that, right, we'll move on now to learn how to output the data. So for example, I have this data frame that we have just now, this DF merge, right? I want to convert it into a file, into a CSV file. So I use this tool CSV, okay? And then you put your file name into your string, and this R represents this is just the raw data that I want. Okay, means the comma will represent the comma, the full stop will represent the full stop inside the file name. Okay, and then indexing false and header true. So when you do that, right? For example, I have this merge data that I merged just now. I want to put this into a file, into a CSV file. So I load this command. And then now if you go to your files inside you should be able to see this. The file name they have created, df underscore merge column.csv. So it's over here. And if you want to download it, you just click on download. The three dots, they appear at the side and click download. And then you should be able to view them. Okay, let me show you what I'm saying. Yeah, so when I load that, it will be into a CSV file here. And this is the data that I got. Okay, so you can try to save your file into that. And we'll go for a 5 minutes break. Okay, So save your file into a CSV file, try it, and then you can go for a break. And then you come back at 8:10. Okay, sorry, it's 8:11. Let's continue. Okay, so just now what we did, the last part was to convert our data into a file. So next, and finish up onto the, and finish up with, sorry, the data processing. So next part, right, we are going to clean the data. So actually data cleaning goes hand in hand with data processing, because as you're processing it, sometimes you realize that, hey, I don't need this extra data, or I need to format this data into a certain style. So we need to clean the data. So what we have went through previously in the last 2 hours or so, right, was data processing using pandas. So data cleaning also uses pandas. So we're gonna learn how to do it. So unstructured data, our data set usually contains different types of data in different formats. So for example, our data might contain colors, state, gender, city, which are not numerical. So we're gonna convert them into some numerical form, or like for example the NA, we're gonna remove them and stuff. So what is data pre-processing, which means data cleaning? Okay, some data values have different ranges, which might cause problems, and we want to convert them into a fixed range. We want to set the range for them. So what I'm gonna do, right, is to clean up the data, and it's very important when we're analyzing data. So yeah, these are the steps. Okay, one example, missing data. So there's a specific rows in our data set which does not contain any information for some specific columns. So one way you can either remove the entire row as we learned just now, or we change that data, the empty data that you want or whatever, into another number. So we're gonna learn how to handle missing values, which is very common in data analysis. We either remove or perform imputation on it. So removing data, what we can use is the drop NA function, okay, inside pandas. So you want to remove the row that has empty values. So we're gonna use we're gonna load a data set missing data Excel file on what's it, inside the drive that I have shared with you guys just now, the link. So we're gonna load this file where it contains missing data, and we're going to remove the rows that has any values. Okay, so the file contains information about a group of people who visited a restaurant on a particular date. So a few ages are omitted because some customers don't want to reveal their age. It's too sensitive. So these customers did not get the discount because on 21st May 2015, customers who are 25 years old and above get to dine in for free. So first time, right? 25 years and above, you get to dine in for free. So we're going to find out the total number of people who enjoyed this perk. So we're going to load this file, Excel file, onto pandas. So the table should look something like this, where there are missing values in each column. Okay. So how do we load the values? How do we load the file? Just like I mentioned at the start of the class, but for those who missed out, you just run this codes here and then choose the file. And then you choose the missing data XLS. So just let it run. And then in order to read the Excel file, the function that we use, just now I asked you all to Google, is called read Excel. Okay, it's no longer read CSV, but because the XLS file, which is an Excel file, we're going to read this data, this file and load it into a data frame. Okay, so we're going to store it into DF. And then if I print the data frame, you should get this here, where there are any values inside the row, inside the column with ages, sorry. So if I want to drop all these rows, for example, this one, Philip, Kathleen, and Nevada. Okay, if I drop all these rows using the drop NA function, so we should get this here instead. Okay, so now all the rows with any values are gone. So we remove the rows with the ages are empty using drop NA. Okay, so later I'll let you try again. Don't worry. So next, right, is we want to remove the column instead. So just like as I mentioned, column will your axis will be 1. So what you can do is inside the drop NA, you assign the axis to be 1. So if you by default it's just by row. But if you want to, for example, remove the entire column, you just put axis equals to 1. And then the age, because only the column with age has any value, so the entire age column gets removed. Okay, so you guys can try now. Try to remove the rows and remove the columns of the missing data using the missing data XLS. So where's the file? Before you guys ask me, I'm going to show you guys the file again. So it's over, it's under session 1, the link that I sent here, missing data files. I'll send the link up again in case people would just join us. So please read the files and then try these codes here. So I give you around like 2 minutes. Okay, sorry, let's continue. So moving on. So everyone should be able to remove rows or columns with missing data. So sometimes, right, if we remove a certain row or column, it will affect the results of our data, right? Because if we remove a certain row, for example, we are reducing the number of people in the restaurant, in this example, and then it will affect the average in the sense. So instead of removing data, so it says here, removing data is convenient, but it's not usually the best case, right? So another method, right, other than removing the data, we're going to edit the data on it, and it's called imputation. So instead of deleting the row, we fill the missing values by some other value instead. So you can put in median, mean, or zero. Okay, sometimes adding the average, like those who didn't add the age, right, just add the average age in the results will be good when you're calculating or when you're performing data analysis. So how do we perform this imputation? So going back to our earlier example, so the customers who did not reveal their age were not eligible for the discount, right? So hence we do not need them in. So for those who didn't reveal their age, we're going to put, instead of removing the entire row, we're going to put their age to be zero instead. Okay. So how do we do that? We're going to use the function fill NA. Okay. So we have our data frame df, and we want to update the the rows or the cell in that case where the age is empty. So what we do, we call the row or we call the column, sorry, dfh, and we use the function fill NA, and we're going to fill the empty values with zero. Okay, and put this value into the original uh, column. And then here we get it. Let's see. Yeah. So just now we have Philip, Kathleen, and Nirida who have NA, right? But now instead of having NA, we're going to fill them with zero using this fill NA function. Okay, yeah. So please try. You can try filling in with instead of NA, the mean instead. So think about how you're going to do that. We'll give you around like 2 minutes to do so. Okay, so let me try going through now. So instead of putting in 0, right, I want to put in a mean age instead. So how do I do that? So I need to get the mean age, right? How do you do that? We can put it into a new variable m. So to get that column, you can use the dot method. So df dot the column name, which is age dot mean. Okay, and then instead of filling in by 0, we put m. Okay, yeah. Then you see Kathleen, Philip, Kathleen, and this Nireda have the same because it's the mean. Okay, some people just not ask me why did I say to not use this dot instead? Because if your column name, for example, first or last name have a space, you can't put df dot last name last space name. It doesn't work like that. There'll be an error. Okay. So for this case, right, you need to use the square bracket instead. Okay. Obviously, there's no this line here doesn't make sense now. You don't get the mean of the last name. I'm just explaining when to use the dot and when to use this square bracket. Okay, with that, right, let's move on. Okay, the last portion. Okay, last 30 minutes. Okay, so hang in there, everyone. Good to see you guys. Hang in there, last 30 minutes, data analysis. What are we going to do, right? After performing the data processing and also cleaning up the data, we can finally uh, analyze the data, like present it into a graphical method. So there are two ways to do it, quantitative and graphical. So quantitative, you can apply statistical methods, like for example, I mentioned earlier, your t-test, z-test, chi-square, chi-square, sorry, and ANOVA test, which you guys will go through next session on Friday. So come Q&A for more of that quantitative. But for today, we're going to do a graphical. Okay, so we're going to present our data in a graphical format. So how do we do it? How do we do it? You will see now. Okay, so let's move on. So I'm going to visualize the data in graphical representation using like charts, by pie charts, sorry, bar graphs, what's that, box plot, sorry. And we're gonna use something called Plotly. Okay, some of you guys might be familiar with this library. So let's see. Okay, data visualization in Python, many well-known libraries which provide this data visualization. So there's also Matplotlib. If you're interested, you can always Google and find out more about it, Matplotlib. But our main focus for today will be on Plotly. Okay, so what is Plotly? It's a Python graphing library inside Python, yeah, which helps us to create all these graphs. So why do we want to use Plotly? So it's equipped with a robust API. Users can create extremely fun and interactive plots. So unlike other Python libraries, Plotly have both online and offline. Yeah. So those are the advantages, I guess. And yeah, we can read on. Online mode is straightforward. Users can view their plots immediately. So let's move on and draw the graphs, okay? Because I know you guys are waiting for it. So how do I do it? You're gonna import plotly.express as px. Okay, so plotly just like pandas is already inside. So you just have to import the module. Okay, we're gonna import plotly.express as px for short. So later on, I'm just gonna put px dot something. So our first practice on drawing. So draw a histogram. So as you guys already know what a histogram should look like this, okay, where the bars are joined together. So how do I draw this histogram? First, I need to have my data, right? So for example, my data, I'm going to put in this data, is like this, okay? X, and I'm going to put it into a list. Okay, I'm storing this list into X, and then I'm going to create a data frame also. Okay, so my data frame is X, where the columns is equal to X. So after I create a data frame, I plot the histogram using plotly, which is px, and I use the histogram function inside plotly. So px dot histogram, the first argument will be my data frame, and the second argument here will be the what is this? Your x-axis, the label on the x-axis, okay, equals to x. Okay, and before here, your x here must be exactly the same as columns. If not, it won't work. Okay, and then I'm just going to print my data. So if you run your code here, so you still have to import pandas because you're going to create a data frame. You should get this thing here. Okay, and your x-axis, x label will have an x here because of this thing here. So go ahead, try this out. I'll give you all around like two minutes. Okay, and try to beautify your plots. Add in titles and stuff. Okay. Okay, let's move on. So I saw some people ask the question on if I load the CS after you have converted the file into a CSV, how do you download the file? You go here and you should be able to see the files that you have downloaded. And then to download it, you just click on the three dots here and click download. Okay. So let me move on. And other than drawing histogram, what can we draw? Box plot. So we're going to use the function box. Okay, so how does a box plot look like? Like this. So we have our data, same data, and we're going to, okay, be careful here. We're going to put columns equals to y. Okay, and then you're just going to plot the data frame and set the y label as y1. So why do you want to put y? You put this first, and then see what happens when you change it to x. Okay, so I'm going to run this program first and show you what it will show. So you got a data frame, df, and you're just going to plot the box plot, and put the y label as y1 over here, and you have this value here. Okay, so try this. You have your data frame, use the function box to draw your box plot, and then include y. Then after you're done, change all the y to x and then see what happens. Okay, for those who don't understand the box plot, right, I'm going to explain first. So the box plot, the bottom line will show you the minimum, the top line is the maximum, and then this box that you see, right, will show you your IQR, interquartile range. So Q1 will be the bottom line of the box, and Q3, which is your third quartile, will show you this line here. So this Q1 will represent the 25th percentile of your data. And this Q3 is your 75th percent. Okay? Yeah, and this line here is your median. So median is not equals to mean. Mean is the average. Median is the middle number. So you have to arrange your data set in order and you find the middle number. That's your median. Okay, and the median is 80.5. So my question to you was why do we have to add in y? What happens if we put x instead? So you realize that your data becomes very funny here, right? Because now they're putting it in x instead, like horizontally instead of vertically. Okay, therefore you don't want to do that. We always want a box plot to be vertically, so we put set y. Okay, so be careful of this. This y1 is just a variable, it's just a naming. You can change y1 to be anything. Okay, so another question here. See, so try changing the y to x, which is what we have done. We see that the data becomes very funny, right? So next question is, what if there are two sets of data, or how do I plot more than one box plot on the graph? Okay, so going back to our example that we have just now about merging the different columns and rows of our class. Okay, so I'm going to print this data frame that we created just now, which is this. Okay, we have the student, class, age, score, ID. So what we have here, I'm going to split it up, and I'm going to have the, I think, what did I put? Age and class. Okay, so I'm going to have the different classes as my different box plots, and I'm going to calculate the score, calculate the age, sorry. So my x-axis, right, I'm going to split them up according to classes, and my y-axis, I'm going to split them up. I'm going to plot the different ages. You can change this to score if you want, and then you should see this here. So you set your x and your y-axis to be the columns that you want inside your data frame. So you can try this. I give you all like 1 minute. Change maybe the age to score, and then you see what happens. Okay, so you can change it, and be careful if I put a different, I put a small s instead, they'll show me an error at this line here, and they say why is not the same name of the column in data frame, because in my data frame the column is a capital S, so must be careful of your capitalization. And then you get here, so the scores for each class nicely in a box plot. Okay, last two, and then we're done. Okay, hang in there. Bar graph. So the difference between histogram and bar graph is that you look here. The difference is there are spaces, right? Spaces for bar graphs. Histogram, they're all joined together. And usually bar graphs we use for categorize data with different categories. Okay, so for example, I have different food items: sushi, pizza, hamburger, and fried chicken, sorry, and the different numbers to it. Okay, so I have two lists. One is the item list, and next one is my number list, which is a value. Okay, so I put them into a data frame, and then I plot the graph using px.bar, using the function px.bar. I put the data frame inside, and I have my x value and my y value. After that, I will just print the data out. So we should get this here. So creating a data frame here, should be of no surprise here. And it should be quite easy. So I won't let you guys go through. Later I'll give you time again after I go through the last one. Okay, last one will be the pie chart. So how do we plot a pie chart? We just use px.pie. Okay, so using the same data frame that we have created just now, we just change the pie from the bar to pie. Okay, and be careful here, it's no longer x and y, but instead it's values and names. So values are the numerical values that you have, okay, which is number of values, and then names will be the x's, right? Because our pie chart, you look here, we have the value and our label. Yeah, label. So labels will be called names. So our values will be assigned to number of students, yeah, which is the column in our data frame, and names equals the food item, which is the column inside our data frame also. So when we do that, we will have a nice pie chart here. Okay, so I'll give you all time to try those out. The pie chart and bar graphs. Okay, so with that, we have come to the summary. So please hang on first. Yeah, so what we have done today was I taught you guys pandas and the difference between data frame and series, and we focus a lot on data frame, how to create a data frame using a list of dictionary, or also how to read these different formats. We focus mainly on CSV, reading files, and using pandas, we learn how to extract rows, columns, how to filter data, how to merge them, how to group them using group by, aggregation function. Okay, actually we have done a lot of stuff here. Filter, joining data, pivoting, and outputting the data, which is quite useful if you want to save your files into a CSV file. Okay, and we also did graphs, draw different graphs. So with that, yeah, we're done. So please do this feedback. Okay, so I'm gonna pause the video here, and you can scan the QR code and do the feedback. So if you want to save the sample codes file, okay, I'm going to show you. If you have the sample codes, if you want to save it, make sure that you save it into your drive. Okay, you just click on files and save a copy in drive. Then you should be able to copy the file into your drive, and you can have access to the sample codes that I went through. Okay, so where are the sample codes? The sample codes are in the link over here. Sorry, I'll show it slower. The link that's shown you here, and then click on sample codes and the version 2. Open with Google Colab at the top. And you should be able to save the copy into your Google Colab, into your drive, sorry. File, save a copy in drive. Okay, yeah, and it'll take a while. So you just let it do its stuff, and yeah, you're done. So hope you have enjoyed the long 3 hours. Okay, maybe 1 hour, 55 minutes. So thanks for joining us, and see you guys on Friday. Okay, so please scan a QR code and do the survey. Okay, thank you. See you guys.